All right, this is a calculation on chemical composition stoichiometry. And we are asked to find the mass of chalcocite, that's an ore of copper, that would contain the same amount of copper contained in 3.68 grams of chalcopyrite, another ore of copper. So we have to work from, let's go for the analysis. We have to work from the mass of chalcopyrite, which is CuFeS2, and then determine the mass of copper present in this particular ore from the given mass, which is 3.68 kilogram. And now work into the required amount of Cu2S. So the calculation will contain 3 units, as we have seen, 1, 2, and 3. So let's get straight off into the solution very quickly. I have to take these traces away. We'll start straight off with the calculation of the molar mass of each of these ores so that we can make use of them in due course. Solution, let's go. Now the molar mass of the first one, molar mass of Cu2S. We're going to make use of the given relative atomic masses. Copper is 64. And now because there are 2 atoms of copper, we'll multiply by 2. Plus relative atomic mass of sulfur, and that is 32. And let's compute this. 64 multiplied by 2 gives us 128. 128 plus 32 gives us 160 gram per mole, the unit of molar mass. This means 1 mole of this compound, copper, Cu2S, has a mass of 160 grams. Let's establish the molar mass of the second ore in a similar manner. Molar mass of CuFeS2. Let's calculate this. 1 atom of copper, 64. Plus that of iron given to us, 56. Then plus, there are 2 atoms of sulfur, so we go 32 multiplied by 2. And we can compute this, of course. 64 plus 56 already gives us 120. And now 32 multiplied by 2 gives us 64. So 120 plus 64 gives us 184 in gram per mole once again. Now the 2 molar masses are well established. Finally, we want to convert this 3.68 kilogram of that ore into gram because the molar masses have gram per mole. So there should be agreement in that unit, of course. So 3.68 kilogram of chalcopyrite actually means in grams, we multiply by 1,000, and that gives us 3,680 gram of the ore. So let us follow up the trend. Now, we want to see the mass of what mass of chalcocite, that's Cu2S, will contain the same amount of copper. So the first question is, what mass of copper will be present in that given amount? Okay, contained in 3.68 grams of chalcopyrite. Let us determine the mass of copper present in 3.68 grams of chalcopyrite. So we work from 3.68 kilograms of chalcopyrite, which has been converted. So let's get straight off into it. We have 3,680 grams of chalcopyrite, CuFeS2. And now we have to rely on the relationships. Dimensional analysis requires elimination of the units on the left based on relationship. So the denominator is the target. How can we bring in the relationship so that we have gram of CuFeS2 in the denominator here? We make use of the molar mass. CuFeS2 here, we have 184 grams per mole. Out of the 184 grams per mole, we observe that 64 grams is contributed by copper, as you can see clearly there. So there are 64 grams of copper present in 184 grams per mole of that ore. And that is a relationship setup. So 184 grams of CuFeS2 contains 64 grams of copper. That's the relationship. 64 grams of copper. And now the third and the final unit. We have to target elimination of this gram of copper here. Already we can see gram of CuFeS2 already cancels out here. So the denominator is the place to go at all times. So target cancellation of gram of copper based on the relationship to the second ore. As we observe in the second ore, out of the 160 grams in 1 mole of the ore, 64 multiplied by 2 here, which is 128, is contributed by copper. So 128 grams is contributed by copper. We go 128 grams of copper is present in 160 grams of that ore, Cu2S. And this is mission completed already, because now by analyzing the units, we have gram of CuFeS2 eliminating gram of CuFeS2, gram of copper eliminating gram of copper, and the prevailing unit is now gram of Cu2S, which is what we are required to find in the calculation. So by multiplying out these values and dividing appropriately, we come up with our final answer. Now, a quick inspection shows that these values are related. 64 divides into 128 gives us 2. That 184 divides into 368 2 times. Yes, of course. 184 divides into 368 2 times. And here comes the extra 0. The calculation continues. Now we have 2 divides into 20 here to give us 10. And by multiplying 10 and 160, we get 1600 gram. 1600 gram of that ore, Cu2S. Cu2S. And because our options are set in kilograms, we decide to divide by 1000 to get our final answer, which is 1.6 kilograms of Cu2S. And this is our final answer, right there in option C. Now, attached to this video are 2 quizzes to test your understanding of the content of this video. I recommend you take the quizzes. And of course, the solutions are provided in when you click the answers, the explanations are provided. In addition to this, there is a link in the pinned comment that enables you to take a quick test on chemical composition stoichiometry. There are 20 questions to be attempted in 30 minutes. I recommend you take the test. This will help you establish your mastery or your understanding of chemical composition stoichiometry. Finally, based on your performance in the test, you may decide to study the full analysis of the topic. And there is therefore a link provided in the pinned comment that will lead you to study the full analysis of the topic. So study, learn, and enjoy. Thank you for being part of this session. And of course, I'll see you in my next video.